So in the video you're about to see, here's the building. We're standing down here on the ground, some of the students are. And we had a tube shaped like this. I dropped a marble in the tube and it went whoop, and it came straight out sideways. Okay? In the beginning of the video, we dropped a tennis ball from here and timed how long it took to hit the ground, and it took 1 second. And you'll be able to calculate how high the window is just from that 1 second fall. That's all you need. Okay? The other thing is we wanted to calculate how fast the ball was moving sideways. And since we knew that the ball fell for 1 second, we measured how far away from the building it was that the ball landed. I keep saying ball, it's actually a marble. It's a marble. We tested the drop time with the tennis ball, and what we actually rolled out of the tube was a marble. So after watching this video, you need to turn in a sheet of paper with a big picture like this and all the math from the video turned in. Okay? Now, I break it down at the end of the video, but as you're doing this, you need to think about it and watch the video and do your math. Okay? So good luck with it. Here we go. Y'all ready to time it? Yep. 1, 2, 3, go. So I'm going to roll this blue marble. It's going to get dropped in this tube up here, and then it's going to go out the window. Now what's important for you to understand is that this tube is perfectly horizontal. So when the marble comes out, it's going straight sideways. It's not going up, it's not going down. Does that make sense? And the edge of the tube is even with the edge of the building. Okay? So here we go. Okay, come up here to the edge of the building. So, we're down here. There's the window. And the marble landed. We marked its spot right there. Okay, so if we back up and we look at the building, and we know we have that little meter stick standing there, we can start thinking about how we're going to solve this problem. And what is the problem? The problem is, with what velocity did the marble come out of the tube? So the marble landed 1.82 meters from the edge of the building. And the edge of the orange tube up there is perfect with the edge of the building. So when we're talking about the marble moving away from the building, it went 1.82 meters in 1 second, because we calculated the drop time of a tennis ball from there to be 1 second. So then we very simply calculated that since the marble came 1.82 meters away from the building in 1 second, that the horizontal velocity of the marble was 1.82 meters per second. And the next thing I would ask you is to draw me a different velocity for the ball, for the marble, because the marble is also going down. So what is the maximum downward velocity, the vertical velocity, that the marble reached before it hit the ground if it fell for 1 second? Well, we calculated that since the marble fell for 1 second, then its downward velocity would have been 9.8 meters per second, because acceleration due to gravity on Earth is 9.8 meters per second per second. So after 1 second of falling, the marble would have reached a velocity of 9.8 meters per second. So now we know its sideways velocity and its downward velocity. So we can talk about the ball going out the window, and we can break it down. Okay. Now there's the window. Okay. Here's the ground. Everybody with me? Now we have the little tube up here, and the marble came straight out of the tube. That's very important. Does that make sense? So if you look, I'm going to draw these arrows like this, and these arrows are all going to be the same length. Now what is happening here? All you have to pretend I'm better at drawing. But all these arrows are supposed to be the same length sideways. So qualitatively, the sideways velocity is equal the whole time. It never changes. Does that make sense? Now, if I draw arrows representing the velocity downward, notice those arrows get longer. Because what's happening on the way down? It's accelerating, yeah. And that acceleration down is going to be 9.8 meters per second every second. Correct? Now there's a formula for that. Acceleration equals change in velocity over time. The acceleration on Earth of something falling is always 9.8 meters per second per second. The time that fell happened to be perfectly 1 second. So the new velocity was 1 times 9.8. Its final velocity downward was 9.8 meters per second. That's its downward velocity right here. Does that make sense? So how did we calculate what this sideways velocity was? Well, we used the same time. The time that the ball fell was 1 second. Okay? Except for now, since the ball's moving sideways, we're going to use the formula of velocity is equal to distance divided by time. We measured that the marble hit the ground right here, 1.82 meters from the building. That's the distance it went sideways. Velocity is equal to 1.82 meters, and it did that. It moved sideways for 1 second. So its sideways velocity was 1.82 meters per second. The sideways velocity and the downward velocity don't affect each other. The fact that something's moving sideways has nothing to do with it falling. Those two arrows are independent of each other. Does that make sense? So the last thing I would ask you and the other people at home is, what is the height of the window? How tall was the window? Or how far off the ground was the window in meters? So calculate that real quick. So the formula for solving how tall the window was is this shortcut formula, XF equals 1/2 AT squared. Now that's from the longer formula that's on your tables. It's from this formula right here, XF equals XI plus VIT plus 1/2 AT squared. But if we're talking about this thing falling, before it fell, how far had it gone? 0. So there's 0 initial distance. Before it started falling down, what's its downward velocity? 0. So that's 0. So the shortcut formula that we use often in this class is XF equals 1/2 AT squared. So XF equals 1/2. The acceleration on Earth is 9.8 meters per second every second. And T squared was 1 second squared. So the seconds mark each other out. And half of 9.8 is 4.9 meters. Does that make sense? So how far does something fall In 1 second, it falls 4.9 meters. And that's it. That's how we can solve this. Does that make sense to everybody?